Hello everybody, welcome back. In the last few videos we started looking at statistical inference, and today we will be looking at another kind of inference. It's called hypothesis test. So let's say that we have a target population, and we are looking at certain parameter about that population. The parameter could be population mean, mean of a variable. It could be, proportion or something else. So we are looking at a population parameter. So we take a sample, and we take a sample of certain size, and then we compute the sample statistic, and we are to use the sample statistic as an approximation to the population parameter, or we want to use the statistic to make inferences about the population parameter. So recall that we looked at a kind of inference before called confidence interval, and when we looked at confidence interval, the goal was to estimate a population parameter. And so now what we want to do is we want to turn our attention to another type of inference. It's called significance test, or test of significance. And in a test of significance, the goal is to assess the evidence provided by the data in favor of some claim about a parameter. So again, the goal is to assess the evidence provided by the data in favor of some claim or statement about a parameter. So maybe the claim is about population mean, or the claim could be about population proportion of something, or it could be a claim about some other parameter. So I'm going to lay out the overall ideas of the test of significance, and then I'm going to fill in the details. So in a test of significance, we have a claim, right? That we have a claim or a statement that we want to assess from our data, and that claim is labeled H0, or the null hypothesis. So the null hypothesis is the think of that as the statement that is being tested. And whenever we are testing a claim, it is it is usually there is usually another related statement, and the other statement is basically the other statement here is called the alternative hypothesis. And what that is basically this is the statement that we suspect is true instead of the null hypothesis. So null hypothesis is the claim, and the alternative hypothesis the alternative hypothesis is the statement that is suspected to be true instead of the null hypothesis. So for example, let's say somebody claims Somebody claims that over the last 20 years, the height of BGSU students increased, and the mean height of BGSU students is now 7 feet, which let's say, not 7 feet, let's say 6 feet. And let's say the 20 years ago, the mean height was 5.7 feet. So somebody is claiming that the height of mean height of BGSU students increased to 6 feet, and 20 years ago it was 5.7 feet. So in that case, the null hypothesis would be that, okay, the null hypothesis would be that the mean height is 6 feet, and the alternative hypothesis in that case would be that the mean height is the mean height isn't as big as claimed, so it is actually less than that. Or another example could be, okay, so we're looking at, let's say, the effectiveness of a vaccine like COVID-19 vaccine, and let's say that the claim is that the vaccine is the effectiveness of the vaccine is 95%. Well, so then the null hypothesis is basically, okay, we're claiming that the effectiveness is 95%, and the alternative hypothesis would be that no, the effectiveness is not 95%; it's less than that. Okay, so in a test of significance, okay, you have two hypotheses: null hypothesis and alternate hypothesis, and the main idea is that you pick a sample and you evaluate the sample statistic, which is the observed value of the sample statistic, and you ask the following question. So again, these hypotheses, they are statements about certain variable and certain associated population parameter. So once you take a sample and evaluate the sample statistic, and which would be called the observed value of the sample statistic, then you ask the following question. Assuming that the null hypothesis is true, is it rare that the sample statistic takes on a value equal to or more extreme than the observed value of the statistic? And if the answer to this question is yes, then what it means is that, so if the answer is yes, it means that a rare event has occurred, right? But rare events shouldn't occur. So therefore, we should reject the null hypothesis and in favor of the alternative hypothesis. And if the answer to this question is no, that is, no, that event is not rare. So okay, if it is not rare, then it could happen. So we fail to reject the null hypothesis. So this is the gist of the test of significance. So now I have to kind of fill in the details here. So whenever we have a test of significance, we have to first of all identify what should be the null hypothesis and what should be the alternative hypothesis. Now, so this has to be first. We have to first come up with this two statements. So this statement needs to be determined first, and then we have to take a sample, and then we have to evaluate the related sample statistic. Okay, so once there is not much to say about it, except that when we pick the sample, it has to be a simple random sample, and then the main detail that I have to fill in is answering this, this part right here. So assuming that the null hypothesis is true, is it rare that the sample statistics takes on a value equal to or more extreme than the observed value, right? So how do we quantify this rareness of this event? So the event here we're looking at is the event of observing the sample statistic that we observed, or something more extreme than that. And so basically the rareness, whether it's rare or not, it's going to be given by its probability. And then of course this part is easy to, once we have a way to quantify the rareness of the event, then we can answer these questions easily. Okay, so let's fill in the details now. So to fill in the details now, I'm going to use an example that's going to help us understand the ideas. So let's say that we are to assess the claim that the mean height of BGSU students is 72 inches. So in this example, the units of the population of units is the entire set of BGSU students, and the variable of interest is x, and denoting height of a student. And we wish to assess or test the null. So what would be the null hypothesis here? So what is it that we are claiming here? Well, we are claiming that the mean height is 72 inches. So that's the null hypothesis. And so this is the statement that is being tested. Now, when conducting a hypothesis test, like I said, we must also specify an alternative hypothesis, which is denoted by HA. And so this is the statement that is suspected to be true instead of the null hypothesis. And for our current example, there are three possibilities for the alternative hypothesis, right? The one is, the alternative hypothesis is that the mean height is less than 72 inches, or it could be that the mean height is bigger than 72 inches, or the mean height is not equal to 72 inches. So there are three possible alternative hypotheses that we can make here. So which one do we pick? Well, it depends on the situation. So let's say that somebody is claiming that over the last 10-20 years, the mean height of BGSU students has increased, and has increased from, let's say, 5.7 feet to 6 feet. So 20 years ago it was 5.7 feet. Today it's 6 feet. So if that's what the claim is, then the appropriate alternative hypothesis should be that the mean height hasn't increased so much. It is in fact less than 72 inches or 6 feet. So we're going to pick the alternative hypothesis to be the hypothesis that the mean height is less than 72 inches. Now I'm pretty sure you can give enough reasons to choose the other two alternative hypotheses in other situations. So now we have determined our null hypothesis and our alternative hypothesis. So that's what we want to assess, right? So what is the next part? So the next part is that we have to collect data in order to assess the claim. So remember, we are making a claim about the mean height of BGSU students. And so we take a sample. Let's say this is the sample that we obtained. This is a sample of 16 measurements of height of BGSU students. So, and then based on this sample, we calculate the sample mean, which is x bar equal to 69.375. So you can calculate the mean of these measurements. You're going to get this. Now this is what we call the observed sample statistic. In this case, this is the observed value of the sample mean. Now, how do we measure? So once I have the, okay, so we did the second step, that is to collect data, make sure that it's a simple random sample. So collect data and then compute the sample statistic, which we did. So now we need to measure how much evidence does the data provide against the null hypothesis and in favor of the alternative hypothesis. So how do we measure this, right? How do we measure evidence for or against the null hypothesis? Well, we're going to use what is called the p-value. And what's the p-value? Well, p-value is a probability, and so basically p-value answers the following question. So assuming that the null hypothesis is true, that is, assuming that the mean height is 72 inches, what is the probability that the sample statistic would take the sample mean here would take a value as extreme or more extreme than the observed sample statistic. So remember, this is the observed sample mean. So what is the probability that the sample statistic would take a value as extreme or more extreme than the observed one? And so that probability is called the p-value. So for our current example then, what are we asking? For our current example, the p-value would be the probability. So the p-value would be that the probability that the sample mean is less than the observed. The sample mean is equal or less than the observed sample mean, given that the null hypothesis is true. That is, given that the population mean height is 72 inches, what is the probability that the sample mean height is less than or equal to the observed sample mean height? So notice that so we are thinking of these values, right? These are the values that provide as much or more evidence against the null hypothesis that mean height is 72 inches. So these are the this range of values of the sample mean here provides as much or more evidence against the null hypothesis than the observed sample mean, 69.375. So this probability, so in this probability then, so the mean is, so let's say, so we're going to assume that x bar has normal distribution. So we are assuming that the mean is 72 inches, right? And we are asking, hey, what's the probability that, so let's say this is 69.375, and we are asking what's the probability that x bar is what's the probability that x bar is less than that. Okay, so to answer this probability question, right, so to compute this probability or p-value, we need to make an assumption about the distribution of the sample mean variable x bar. So the distribution of X bar, so what is the null distribution of X bar? Null distribution of X bar is the distribution of X bar assuming that the population mean height is 72. So assuming that sigma is known and sigma is equal to 2.8, let's say, then the sampling distribution of X bar is normal with mean equal to the population mean height 72, and the standard deviation of X bar would be population standard deviation over the root of sample size, and that turns out to be 0.7. So this is the probability model that we are using for the distribution of X bar. So now if that's the case, then we can now easily compute the p-value. So the p-value is the probability that X bar is less than 69.375. This is the observed sample statistic given that the population mean height is 72. Well, we're gonna write this probability in terms of the standard and normal distribution. So the probability that z is less than, so from 69.375, so remember, making this assumption that the mean is 72, it means that the X bar has normal distribution with these two parameters. So from 69.375 we subtract 72, and then we divide by the standard deviation, and so this probability is the probability that z is less than that. And if we simplify this, we get that the probability that z is less than negative 3.75, and that probability is equal to 0.0000884, which is about 1 over 11,307. So this p-value is very small, right? It tells us that the possibility that this event is going to occur, that is the possibility that we are going to get a sample mean less than the observed one, is 1 out of 11,307, right? So is this p-value small enough? That we have to set a level. We have to set what we call the significance level alpha. So let's say we set significance level alpha to 0.1% or 0.1%, and that's 0.001. And so this is our standard. Like if the p-value is less than that, we're going to say, well, that's a very small p-value. And this is what we have to set up. Whoever is doing the test has to set up. So since the p-value is less than the standard significance level of 0.1%, we reject the null hypothesis. So the reason is, see, the small p-value here indicates that the data is providing very strong evidence against H0, the null hypothesis. A small p-value indicates that if the null hypothesis were true, then the observed sample statistic should be a very rare event. And the fact that a rare event has occurred is under the assumption of H0 is evidence against H0. So if you look at again the p-value, it's the probability that the sample mean takes on a value less than or equal to the observed sample mean, given that the population mean is 72. Well, if this p-value is very small, that means it's telling us that the event of observing a sample mean less than or equal to the observed one is very low, and should be the event of observing a sample mean less than the observed one is a very rare event. And if a rare event has occurred, that's an indication that the assumption that we made about the population mean is not correct. So again, the small p-value indicates that the data is providing very strong evidence against the null hypothesis. Small p-value indicates that if the null hypothesis were true, then the observed sample statistic should be a very rare event. The fact that a rare event has occurred under the assumption of the null hypothesis is evidence against the null hypothesis. Okay, so the result of a null hypothesis is a decision to either reject the null hypothesis or not reject the null hypothesis. So we reject the null hypothesis when the p-value is small. And how small of a p-value you need, well, that depends on what standard you set. And the not reject the null hypothesis is when the p-value isn't so small. And so the immediate question that you should be asking is, what is the criteria for what constitutes a small p-value then? Well, again, like I said, this is decided by the person conducting the test, and the most common standard for this is that the p-value is less than 5%, and so this 5% is the chosen cutoff or critical value, and it's denoted by alpha. This is called the level of significance, and you have to set the level of significance ahead of time. So 5% is kind of pretty standard, even though all right. So the level of significance is provided must be decided by the person who is conducting the test. So in our example, we obtained the p-value as 0.0000 0.0000884, which is less than 0.001, and let's say we set our significance level to that, and so and we rejected the null hypothesis because our p-value came out to be less than the standard that we set as the level of significance here. So we say that the test is statistically significant at the level 0.1%. Okay, so let me end this video by doing a couple of quick examples, and in the next video I will do another elaborate example. So let's say that the mean nicotine content of a brand of cigarettes has the advertised value of 1.4 milligram. A health advocacy group would like to test whether mean nicotine test content is indeed as advertised. Should the advocacy group do one-sided or two-sided test of significance? And so in this case, I would say that the null hypothesis is, of course, that the nicotine content is 1.4. So that should be the null hypothesis, and because we are suspecting that in this case you would suspect that they are not being honest, and they are putting a value that is less than the mean content. So in this case, the alternative hypothesis would be that the mean nicotine content would be bigger than 1.4. And here is another example. Let's say that we have this bags of tomatoes, and each bag of tomatoes is labeled 227 grams. So this is the mean weight of all these bags. And should the quality control manager carry out a one-sided or a two-sided test here? So, well, in this case, it depends on who's doing the test. So, as a quality control manager, maybe that for the company who's producing this, you don't want the mean to be less than 227, the mean weight. You also don't want the mean weight to be bigger than 227. So in this case, I would say that the alternative hypothesis is that the mean weight is not equal to 227 grams. Here's another example. Let's say that FDA is testing whether a generic drug has an absorption extent similar to the known absorption extent of the brand name drug it is copying. It is noted that higher or lower absorption would both be problematic. Should we do a one-sided or a two-sided test here? Well, clearly, in this case, we should be doing a we should be doing a two-sided test because both higher and lower absorption would be problematic. Going back to these examples with tomato bags, now if it is a, like I said, the alternative test will, the hypothesis will depend on who is doing this. As a consumer advocacy group, maybe, they would be worried that the claimed mean weight of these bags is actually less than the claimed mean weight. And in that case, the alternative hypothesis would be that the mean weight is less than 227 grams. All right, so let me stop here, and in the next video, we'll do another example on hypothesis test.